So, welcome back to our Python series. From this episode onward, we are going to not just learn theory, but also write code and build logic. That means we will understand how Python thinks and how to implement that thinking into programs. Today, our focus is on conditional statements. Conditional statements are the tools that allow your program to make decisions. They decide what the program should do based on different situations. Without conditional statements, Python would just follow instructions step by step, blindly. With them, it can choose different actions depending on the input or situation. By the end of this episode, you will understand what conditional statements are, the types: if, elif, else, how to use operators with them, why indentation matters, how Python checks conditions step by step, how to apply them in real-world examples, and we will explain everything slowly, step by step, so that even if you are completely new, you can follow along. Let's start with the basics. What are conditional statements? Conditional statements are instructions that allow your program to make decisions. Think of them like questions you ask Python. For example, is this person old enough to vote? Is this number positive or negative? Did the user enter the correct password? These questions always have true or false answers. If the answer is true, Python will do one thing. If the answer is false, Python can do something else. This is how we give intelligence to our programs. It is like teaching Python to think a little. Conditional statements are the first step toward dynamic programming, where the program can react to different situations instead of just following fixed instructions. In Python, we have three main types of conditional statements: if, elif, and else. If statement. The if statement checks a condition and executes a block of code only if that condition is true. We write it in VS Code like this: if condition, print, this code runs only if the condition is true. Here, the keyword if tells Python we are making a decision. The condition after if is what Python evaluates. If the condition is true, Python runs the code inside the block. If the condition is false, Python skips this block and moves on. Think of it like asking Python a question. If this is true, do this. Elif statement. Sometimes one condition is not enough. We want Python to check multiple possibilities. That's why we use elif, which stands for else if. In VS Code, it looks like this: if condition 1, print, condition 1 is true. Elif condition 2, print, condition 2 is true. Python first checks the if condition. If true, it runs that block and ignores the rest. If false, Python moves to the elif condition. If true, it runs that block. You can have multiple elif statements to handle several possibilities. Else statement. Finally, we have else, which is the fallback option. Else print, all previous conditions were false. Else does not need a condition. Python executes this block only if all previous conditions are false. Think of it as saying, if nothing else matched, do this. Together, if, elif, and else let your program handle multiple scenarios intelligently. Now that we know the types of conditional statements, let's understand why we even use them. Conditional statements are used to control the flow of a program. Think of it like this: without conditions, Python would just do one thing after another in order, like following a recipe exactly as written. But in real life, we don't act blindly, we make decisions. Conditional statements allow Python to make choices, just like we do. Let me give some examples. 1. Checking age. Suppose you are writing a program that checks if someone is old enough to vote. The program needs to decide what to print: you are eligible or you are not eligible. This is done using a condition. 2. Validating login. In an app, when a user enters a username and password, the program checks if the credentials are correct. If true, allow login, else show an error message. 3. Comparing values. You may want to find the largest number among 3 numbers. Python can check each number using conditions and decide which one is the largest. 4. Controlling loops. Sometimes we want loops to continue only under certain conditions. Conditional statements help control when loops start or stop. 5. Games and AI. Imagine a game where a character jumps if an obstacle is near. Python needs to decide what action to take based on conditions. Similarly, in AI, conditions are everywhere for decision-making. So basically, conditional statements make programs dynamic. They turn Python from a passive machine into something that can react intelligently to input or situations. Remember this. Conditions are like questions we ask Python. Python answers with true or false, and depending on the answer, it runs the corresponding code. That's why conditional statements are essential in almost every program. Hmm. Now let's understand how Python evaluates conditions step by step. The flow is simple. 1. Python first checks the if condition. If true, runs that block, skips everything else. 2. If false, Python checks elif conditions one by one in the order they appear. 3. If none of the conditions are true, Python executes the else block. Example to understand flow. If temperature 40, print it is very hot. Elif temperature 30, print it is warm. Elif temperature 20, print it is mild. Else, print it is cold. Suppose temperature equals 35. Python first checks 3540, false. Then it checks 3530, true. Python prints it is warm and stops checking further. The other elif and else blocks are ignored because Python stops at the first true condition. This is why order of conditions is important. Put the most specific conditions first and the most general ones later, ending with else as the fallback. Of conditional statements. All right. Now let's take everything we learned, the meaning of conditional statements, why we use them, how indentation works, how Python reads conditions, and let's apply all of that in real examples. Example 1. Checking if someone is eligible to vote. In the first example, imagine we want to check if a person can vote. In many countries, the voting age is 18, so we want our program to decide if the person is 18 or not. We will write something like this in VS Code. Age is equal to 17 in the next line. Write, if the condition age is greater than or equal to 18, then print you can vote in the else block. Write, print you cannot vote. Now, let's break this slowly and carefully, one line at a time, and explain what each part means and why we write it that way. Line 1, age is equal to 17. Here we are creating a variable called age and giving it the value 17. Age is equal to 17. We store the person's age in a variable named age. So, what this does, Python remembers the number 17 and calls it age. Later, we will ask Python a question about this number. Line 2, if the condition age is greater than or equal to 18, now we write an if statement. We are asking Python a question. The keyword if tells Python that a decision is coming. The condition is age is greater than or equal to 18, which we write by using core. The symbol greater than or equal to. We are asking, is the stored age value 18 or more? Python checks the value of age, which is 17, and compares it with 18. Because 17 is not greater than or equal to 18, this question is false. The line after this, if, must be indented because the indented lines belong to the if block. Line 3, print, you can vote. This line runs only if the condition is true. Inside the if block, we put the action we want Python to do if the condition is true. Here the action is to print the message, you can vote. If the question returned true, Python will run this line and show the message. But because our condition was false for age 17, Python will skip this line and not print it. Line 4, else is the fallback. It means if none of the previous conditions were true, then do the following. Else has no condition. It runs only when the if condition was false. Print, you cannot vote inside else. This indented line under else is what Python will do when the if condition is false. So when age is 17, Python executes this line and prints you cannot vote. The point to consider here is only one branch runs, either the if branch or the else branch, never both runs. Okay, now let's simulate the code behavior with simple examples. Let's run the code. It will show answer as you cannot vote because we have mentioned age is 17. The question is age greater than or equal to 18, it becomes false. So Python skips the if block and executes the else block. So in the output, you can see you cannot vote. Okay, now let's modify an age and now set age is equals to 18 here. Age is 18. The question is age greater than or equal to 18 becomes true because 18 is equal to 18. Python runs the if block and prints you can vote. The else block is skipped. Okay, similarly, let's see for age is equal to 21 here. Age is 21. The condition is true because 21 is greater than 18, so Python prints you can vote. You must keep in mind some points, which are 1, types matter, as age is a number or we can say an integer. If we get age from a user as text, we must convert it to a number before comparing. Otherwise, the comparison may not work as expected. The comparison operator, this operator greater than equal to checks both greater than and equal to in one check. That's why age 18 qualifies. Indentation is how Python knows which lines belong to if and which lines belong to else. Only one branch runs. Python will run only the first block whose condition is true. With if and else, there are only two choices, either the if runs or the else runs. Why we use this? We use this pattern whenever we need to decide between two things. For example, whether to allow access, whether to display an error, or whether to enable a button say. You can try this by yourself. Here, change the age to 12, 17, 18, and 25. Watch what gets printed each time. Notice how the answer changes only when the condition becomes true. So that's the if-else pattern in simple terms. Assign a value, ask a question with if, run the if block if true, otherwise run the else block. Only one path runs, and indentation tells Python which lines belong to which path.